Let's go to my screen and see what our plan for the day is. Number one, we are going to have a look at relative velocity, the ideas behind it, the main and big ideas behind it, and number two, we will be taking a look at vertical projectile motion. Let's see what our relative velocity is all about this afternoon. What is the plan? There are two big ideas that I would like to bring to your attention. The first is that velocity is a vector. That means you always have to bear in mind the magnitude, the size, the how much of it, and of course, you have to indicate the direction. Next point is just as important. This is a powerful tool that we have. If we have the velocity of A relative to r, and if that velocity is 50 meters per second east, then if we change the subscripts around, please note A relative to r, and we then have r relative to A, this is how we change that. It becomes in the opposite direction. Please note A relative to r and r relative to A is changing the direction of AR to RA, then becomes minus AR, and that number, that magnitude then becomes the opposite direction 50, and of course, the opposite direction of east is west. So, relative velocity, two big ideas, let me emphasize that. It is a vector, always magnitude like 50 and always direction, either positive direction or negative direction, or if you will, east and west. And now for the plan. Today we are going to do activity 1.3, page 25 in your books. I would like all of you to find it, and we are going to look at questions number 1 and 2 of activity 1.3, and for homework we would expect you to do question number 5 on page 26. Let's look at our slide quickly and see what happens there. Okay, so now we are on page 25. We are going to do the vectors in the same direction, relative velocity. Let's look at 1.1. 1.1 suggests the following to you. I don't have the question right in front of me now, but I do remember the question. It says that you have a vector VA, vector A, and it is due north 30 meters per second. It's a car traveling on a road, and this car we call vector A, and it's traveling due north at 30 meters per second. There is a second car which is also traveling due north with a velocity of 45 meters per second, and we call this vector B. The question wants to know from you, what is the velocity of A relative to B? In other words, what is our vantage point? What is our viewpoint? It is B's velocity of A relative to B. So, B is the point that we view the velocity from. So, if I can just quickly give you an idea here, we view it from this point and we are looking at A. Its velocity of A relative to B. B is our vantage point. So, it is from there down this way, and that is what we mean. And you can clearly see that that 30 plus the 15 is 45, but it is in the opposite direction. Let us see how we do this in mathematics. Let us see how we worked it out, and you take it down if you want to. You take north as positive. Remember, one of the comments we made was that velocity is a vector. So, you have to choose one direction as positive, and because both these vectors were pointing northwards, I took north as positive. So, let us read this slowly, and I am going to ask you to repeat it. The velocity of vector A relative to B, that is one velocity relative to that one. How do we write it with the subscripts? We say it's the velocity of A relative to the road. So from the roadside, that's my vantage point, that's my viewpoint. From the roadside, A relative to the road, A relative to the road is in that direction, and it is 30 meters per second. Good. So it's 30. I'm adding it to the velocity of the road relative to B. So it's the road from B's perspective. So it means I am looking at that velocity from B's perspective. That's why B is last. That way, and I can see it is 45, but in which direction? It is now in a southerly direction. Remember how we read this? And therefore I put a negative sign in front. And my answer, if I add those two with my calculator, I get minus 15 meters per second. Let's just go over that one more time. Velocity of A relative to B, you understood how I got that one? And now I write it out as velocity of A relative to the road. In other words, here's where I stand. What is A's velocity? 30. In which direction? Northerly direction. What is the sign northerly? Positive. Now if I say the velocity of B relative to the road, then it would be 45 in that direction. From the road, what is B doing? 45 meters per second. But I'm writing it out, and this is a standard way of writing it. I'm writing it from the road relative to B. In other words, I'm standing here. So what is the velocity in that direction now? It's minus 45. And that's how I got the minus 15 meters per second. And therefore, I can write that the velocity of A relative to B is therefore minus 50 meters per second, or 15 meters per second due south, which is that answer there. The second part of the question wanted to know from us, what then will happen if I change these two around, if I have the velocity of B relative to A? Let's first see how I write that. So the velocity of A relative to B is minus 50 meters per second, coming from that answer. But now I change those subscripts around. In other words, I'm changing direction. Velocity of B relative to A is now plus 50, not minus 15, opposite direction. Remember, in physics, a plus and a minus indicates direction. And therefore, it means 15 meters per second due north. I would like you to practice this if you have a problem with this, but let's look at another example, perhaps things will clarify. We now go to number 2. And okay, someone wants to know, why does the plus 45 change to the negative 45? Remember, when I stand here and I view this vehicle, it's in a northerly direction, so the sun is positive. But when I rewrite it, not B relative to the road, in other words, I view it from the road, then it is 45. But when I say I view the road relative to B, it means I'm standing here now and I'm watching the road moving, so to speak, and that is in the opposite direction. That's why I changed to negative 45. Okay, let's look at another example and see. This is example number 2 for you to look at. Okay, let's say that we have two vectors now in opposite direction. Here's my road, and one of the vectors is going in a in an easterly direction. I will make that plus 20. What would happen if I have another vector going in that direction? It would also be in a positive direction, if I choose that direction to be positive. But what now if I have V vector y and I change it in this direction? Do you understand? That is now the opposite direction to that one, positive direction, negative direction. Everybody got that? So let's look at how we write this in physics. We take east as positive. In other words, this direction is positive, makes sense? Therefore, watch the way I write it. The velocity of x relative to y. I can break it up into two parts. Note how I do it. The first one with regard to the road, and then the road with regard to the second one. So, the velocity of x from the road's perspective. Velocity of x from relative to x, to the road, is the road sees is going that way. So it's plus 20. But the road relative to y, in other words, I'm standing on this side and I'm watching the road move, and the road is moving in the opposite direction. There we go. And what was the velocity of the road? Minus 35. So therefore, I change the total, if I add those two, becomes 55 meters east. Okay, let's look at the second part of this question. If I go to the screen again. All right, so now we know that the velocity of x relative to y is 55 meters per second. Now what if I change those subscripts around? What does that mean? I'm changing direction. Okay, that means I'm changing the direction, and then I get a different direction. That was a positive direction. This is now a negative direction, and therefore if I multiply that out, it becomes minus 55. It is no longer east, it's now opposite direction. It is therefore the westerly direction. Ensure that you understand, 1, the subscripts, 2, the change in direction if we switch the subscripts around, and thirdly, when do we add and when do we subtract.